Welcome. We are starting a series where we are going to complete the syllabus of class 11th and class 12th according to the boards. And today we will be starting with the first chapter of class 11th, units and dimensions. I believe that if physics will be studied in order from chapter first to chapter last, it helps for the better understanding for the student. तो आज का जो चैप्टर है वो यूनिट्स एंड डायमेंशंस का पहला वीडियो आज आ रहा है। 3 वीडियोस आएंगे। पहले वीडियो में हम जो एक्सप्लेन करने वाले हैं हम पढ़ने वाले हैं यूनिट्स एंड डायमेंशंस के फिजिकल क्वांटिटीज क्या होती है। हम बात करने वाले हैं डिराइव्ड क्वांटिटीज और बेसिक क्वांटिटीज के बारे में। डिफरेंट सिस्टम ऑफ यूनिट्स हमारे पास क्या क्या है एंड हाउ कैन वी कन्वर्ट वन यूनिट इनटू अनदर यूनिट। इसके बाद आप पढ़ेंगे प्रिंसिपल ऑफ होमोजेनिटी क्या होता है और एक डायमेंशनल फॉर्मूला कैसे निकालते हैं। एंड वी विल आल्सो स्टडी दैट हाउ वी कैन डिड्यूस रिलेशनशिप्स बिटवीन डिफरेंट फिजिकल क्वांटिटीज। सो दिस इज गोइंग टू बी ऑल अबाउट today's video. I hope you'll stay with me for this. Starting from your units and dimensions, what is a physical quantity? First of all, जो पहला टॉपिक है हमारा ये फिजिकल क्वांटिटीज के बारे में है। What is a physical quantity? तो हमने इसको डिफाइन किया है। Physical quantities are measurable characteristics or properties of a physical object or phenomena. Physical quantities वो quantities होती है जहां पे हम किसी भी चीज उसको इंक्लूड करते हैं जिसको हम मेजर कर सकते हैं। ठीक है, ये वो कोई चीज हो सकती है लाइक ऑब्जेक्ट, कितने ऑब्जेक्ट है, ठीक है, वी कैन इंक्लूड, और वी कैन इंक्लूड एनी फिजिकल फिनोमेना जिसको हम क्वांटिफाई कर सकते हैं। से फॉर एग्जांपल फोर्स। फोर्स जो है कोई फिजिकल ऑब्जेक्ट नहीं है, लेकिन फोर्स एक फिजिकल फिनोमेनन है जिसको हम क्वांटिफाई कर सकते हैं। तो फिजिकल क्वांटिटीज वो चीजें होती है जिसमें हम चीजों को मेजर कर सकते हैं। यू नीड टू अंडरस्टैंड व्हाट इज नॉट अ फिजिकल क्वांटिटी। अगर हम बात करते हैं इमोशंस की, से फॉर एग्जांपल हम बोलते हैं लव। लव इज नॉट अ फिजिकल क्वांटिटी। वी कैन नॉट मेजर हाउ मच वी लव समवन और वी कैन नॉट मेजर हाउ मच वी डोंट लव समवन। ओके, हर एक फिजिकल क्वांटिटी के 2 एट्रीब्यूट्स होते हैं टू क्वालिफाई फॉर द फिजिकल क्वांटिटी। वर्ड्स क्या क्या है? एट्रीब्यूट नंबर 1, इट हैज अ न्यूमेरिक वैल्यू। जब भी आप किसी चीज को मेजर करोगे, क्वांटिफाई करोगे, इसका एक न्यूमेरिक वैल्यू होगा। से फॉर एग्जांपल 5 मीटर्स। ओके, इसमें जो 5 है, दिस पार्ट इज इंक्लूडेड एज न्यूमेरिक वैल्यू। ओके, एंड उसके बाद इसका एक होता है यूनिट। व्हाट इज अ यूनिट? यूनिट वो बेसिस होता है जिसके रिस्पेक्ट में हम कोई मेजर करते हैं। से फॉर एग्जांपल अगर मेरे पास ये एक पेन है, आई कंसीडर दिस एज यूनिट। आई कैन से माय हैंड 1 2 and 3. Okay, I can say my hand is 3 times of this pen. So this pen became the reference for the measurement. That's why it is a unit. And the measurement of my pen is a physical quantity. I quantified it as 3 times pen. Okay. Okay, so unit is a standard for the measurement. So what we understood that a physical quantity has 2 things, a number and a unit. It can be represented as n and u, where n represents the number and u represents the unit. Move to the next thing. How many type of physical quantities do we have? Okay, we have different type of physical quantities. We structure physical quantities in different ways. One way is that we structure physical quantities, we differentiate physical quantities on the basis of dependence. Okay, on the basis of dependence on other quantities, we have 2 type of quantities, 2 set of quantities. One is called as fundamental quantity and another is called as derived quantity. ठीक है, एक क्वांटिटी ऐसा होता है जिसको हम बोलते हैं फंडामेंटल क्वांटिटी या बेसिक क्वांटिटी, और दूसरी क्वांटिटी हम बोलते हैं डिराइव्ड क्वांटिटी। व्हाट इज ए फंडामेंटल क्वांटिटी और ए बेसिक क्वांटिटी? डेफिनेशन साउंड्स Basic quantities are the fundamental physical quantities that cannot be defined in terms of other physical quantities. They are the building blocks of measurement and are independent. वो क्वांटिटीज जिनको आप फंडामेंटल क्वांटिटीज, आप इस बात को ऐसे भी समझ सकते हैं. सो फॉर एग्जांपल हमारे पास अल्फाबेट्स है. अल्फाबेट्स जो है हमारे पास वो फंडामेंटल्स बनाते हैं इंग्लिश लिटरेचर के. ठीक है, बाकी सारे वर्ड्स जो है ये डिराइव होते हैं इन्हीं अल्फाबेट्स से. सो वी कैन से अल्फाबेट्स आर द बिल्डिंग ब्लॉक्स ऑफ अ लैंग्वेज. इन द सेम वे फंडामेंटल क्वांटिटीज आर द बिल्डिंग ब्लॉक्स ऑफ द मेजरमेंट. समझ आ रही है मेरी बात? There are 7 fundamental quantities: length, another mass, third electric current, time, thermodynamic temperature, amount of substance or luminous intensity. Okay, what are the units for all of them? वो हम आगे देखेंगे. ठीक है. Now what is a derived quantity? How do we define a derived quantity? हम क्या बात quantities जो आप fundamental quantities से derive करते हो. ठीक है, इन्हीं को बोलते हैं हम derived quantities. एग्जाम्पल वेलोसिटी. हमने वेलोसिटी को कैसे डिराइव किया? अगर हम देखें वेलोसिटी जो है ये होता है बराबर डिस्प्लेसमेंट बाय टाइम. ओके, अगर वेलोसिटी हमारा डिस्प्लेसमेंट बाय टाइम के बराबर है, जो हमारा डिस्प्लेसमेंट होता है इट इज अ सॉर्ट ऑफ लेंथ. सो वी कैन से इट्स लेंथ बाय टाइम. व्हाट हैपेंड? टू फंडामेंटल क्वांटिटीज ओके गॉट टुगेदर अंडर द ऑपरेशन ऑफ डिवीजन and they gave us a derived quantity known as velocity. समझ आ रही है मेरी बात? In this way we can have derived quantities defined and we have the example of derived quantities here. इतना ज़्यादा important topic नहीं है. It's not that important. You can easily understand it by going through the definitions. I'm including it so that your concepts are very much clear. Okay. Now we are going for what are the different system of units. Okay. In physics, there have been a very majority, the diversity of the units out there. Okay, but as far physics is concerned, as for the popular unit system of units are concerned, I have included here. The first system is CGS system. What we used to do in CGS system is that we used to measure length in centimeter. Okay, we used to measure mass in grams and we used to measure time in seconds. So it's that sort of measurement where you have to use centimeter for the measurement of length, where you have to use gram for the measurement of mass, and we have to use second for the measurement of time. Okay, we have the CGS system and the popular units. So for example, in CGS system force is to be measured in dyne. Okay, and in CGS system energy is measured in erg. Okay, now we have another system called as MKS system. What is MKS system? MKS system is that very system where we measure length in meters, where we measure mass in kilogram, and where we measure time in seconds. This is the unit that we called as MKS unit. And force in MKS unit is to be measured in joule. The joule is the unit for the force, and for energy it is going to be, for force it's going to be Newton in MKS system, and for energy it's going to be joule. Now we have one more system called as FPS system. Length was to be measured in foot, mass was to be measured in pound, and time was to be measured in second. Now comes the system that has the universal acceptance, and that's called as SI system, or we say at International System of Units. Under International System of Units, we're having 7 fundamental quantities, and the 7 fundamental quantities are to be measured as: for length is to be measured in meter; for mass is to be measured in kilogram; for time is to be measured in seconds; for luminous intensity it has to be measured in candela; for temperature it has to be measured in Kelvin; for electric current it has to be measured in ampere; and for I hope I have covered the time. So this is about all 7 the fundamental, or amount of substance is to be measured in mole. Okay, so these are the fundamental quantities, and this is the measurement how we do it. Now coming to the dimensional formula, from here the real things get started. What is a dimensional formula? If we have a derived quantity, okay, अगर हमारे पास एक डिराइव्ड क्वांटिटी है, लेट्स सी टू द डिराइव्ड क्वांटिटी, से फॉर एग्जांपल और वेलोसिटी इज गोइंग टू बी इक्वल, velocity is equal to length by time. Okay, if I am going to put length and time like this in the brackets L1 t minus 1, so I structured it. This would be called as dimensional formula for velocity. What do we mean by dimensional formula now? Dimensional formula is an expression that shows us how quantities are related with the fundamental quantities, how a derived quantity is related to a fundamental quantity. That is the job of dimensional formula to say us. Okay, like velocity is length by time, or we can say V is equal to L1 t minus formula. How we can find the dimensional formulas? There are the first step is to be write down the formula, write down the actual formula. Say for example, if I have to find it for the mass, for force is equal to mass times acceleration. My first step, I would write down the formula. My second step is going to be, on the right hand side, whatsoever quantity is a derived quantity, I have to break it into fundamentals. How I can break it? Write their formula. For example, it is F is equal to M. For acceleration, I would write velocity by time. Okay, now what? Now from the LHS side, we have M and T as fundamental quantities, but velocity can be changed again in the fundamental quantities, that is length by time. Okay, now we're going to multiply them. The force comes to be equal to M1 L1 t square, or I can write it like M1 L1 t minus 2. Got it? The dimensional formula for force is M1 L1 t minus 2. Let's do one more example for the gravitational constant, because it's frequently asked in exams. What is the dimensional formula for the gravitational constant? It is, how we do it, F is equal to G M1 M2 by R square. First of all, we need to find the dimensional formula for gravitational constant. What we are going to do, we are going to separate it. How we are going to separate this? We are going to write the equation as F R square by M1 M2 is going to be equal to G. Okay. For force, I'm going to write the dimensional formula that we have just proved. It is M1 L1 T minus 2. For R square, as it is the length, I can write L square, and for M1 M2 the units are going to be same, I can write as M square, which are going to be the dimensions of G. Okay, how I'm going to put it? It will come like M1 L3 T minus 2 into M minus 2. Now if you are going to do simple maths, it's going to come equal to this. This is the dimensional formula for G. I hope you got it. The dimensional formula for G is M minus 1 L3 T minus 2. Okay, so this is how we find the dimensional formula for the derived quantities. Now what we have is called as principle of homogeneity. What does principle of homogeneity says? Principle of homogeneity says you cannot add, you cannot subtract, or you cannot equate two quantities with different dimensions. You cannot add, you cannot subtract, or you cannot equate two quantities with different dimensions. How I put it in the definition, it is the principle of homogeneity of dimension states that an equation is dimensionally correct. An equation is correct only if the dimensions of all terms on the both sides of the equation are same. Of every term on the both sides of the equation are same. The principle of homogeneity is used to verify the correctness of equation. With the help of principle of homogeneity, we can find how correct an equation is. Let's give an example for the principle of homogeneity. We have an equation from kinematics. What is it? S is equal to ut plus 1 by 2 at square. If this equation has to be dimensionally correct, the measurements or the units for each term has to be equal. For what does it mean? The dimensions of S has to be equal to the dimensions of UT, and that has to be equal to the dimensions of AT square. Pure number has no dimensions. Okay, guys. If you have a pure number like the way we have in the equation 1 by 2, it has no dimensions, so you don't have to write it. How we are going to do it? S, what is S? Is displacement having the dimensions of length. What is velocity? It is L by T multiplied by T. You can cancel this T and this T. Okay. As 1 by 2 has no dimensions, we can write what are the dimensions of acceleration? It's velocity by time. Then you will write it 1 by T into L by T, and it will become L1 T minus 2. Or you can write it L by T square into T square. So you can see easily L is equal to L plus L. What does it mean? It means that the dimensions of each and every term are equal. It means the equation is right. If the dimensions are not equal, the equation is not right. Okay, I hope you guys understood what principle of homogeneity is. Am I clear? 100%. Okay. Now we have one of the big problems for the students. Listen, guys. This is important. Conversion of units is important. The reason it is important because no matter what numerical you're doing, whether of NEET, JEE, IIT, or even in boards, sometimes you get answer in different units, and the options which are there, they are in different units. So it is a basic, it is a fundamental that you must know how to convert one unit into another unit. For that, there's a table which you have to remember, which will say you that how many meters or how many centimeters, like the way 1 meter is 10 raised to power 2 centimeters, and 1 kilogram is 10 raised to power 3 grams. Okay, you write it like this way. Okay, 1 kilogram is equal to 10 raised to power 3 grams. So these converging factors you got to remember. Okay, how we change the unit? As in the definition of a physical quantity, we said a physical quantity is made up of two things, a number and a unit. If we have to change a unit of something, its number will be changed. Okay, how it will be changed, we'll try to find out here. Let's write it like this. We have N1 U1 is equal to N2 U2. We will try to understand with an example. Say for example, we need to convert 5 kgs in grams. How we are going to do it? We will write N1 is over 5, U1 is over kg, gram is over U2, and we need to find N2. What is N2? Okay, what is the formula? N1 U1 is equal to N2 U2. What is it? 5 kg is equal to N2 gram. Now what we are going to do? We are going to use the converging factor which we have remembered. What we will do? 5 in place of kgs. We will write it like this. 10 raised to power 3 grams is equal to N2 grams. This and this would be cut, and it would be like 5 into 10 raised to power 3. So what I will say, 5 kgs is equal to 5 into 10 raised to power 3 grams. This is how you convert a unit. Okay, it's a very easy framework that I am giving you. Now let me give you a framework. Like for example, if we have to convert force, okay, I have 5 Newton force. I have to say how much dyne it is. We know, as we studied earlier, dyne is the CGS system of force, okay, where we have to use length in centimeters, mass in grams, and S means time in seconds, okay? Okay, so the question was that how we are going to convert 5 Newton into dyne. I'll write the same formula. N1 U1 is equal to N2 U2. For N1, I have 5. Okay? In place of N1, I have 5. For Newton, I will write the dimensional formula. What is the dimensional formula for the force? M1 L1 T minus 2 is equal to X. Okay? I would write here M dash 1, L dash 1, or T dash minus 2. Why I'm writing it in dash? Because here we have to measure in CGS, here we have to measure in SI. Now what are the units in SI system? It will be like 5 kg meter per second is equal to x gram centimeter per second. Per second cancel. I'd write it like 5. For here I would like 10 raised to power 3 grams. For meter I would write into 10 raised to power 2 centimeter is equal to x gram centimeter. Gram and gram will be cancelled, centimeter and centimeter will be cancelled. X would be equal to 5 into 10 raised to power 5. Okay, so I can say 5 into 10 raised to power 5. Oh, yeah, into 10 raised to power 5 dyne is equal to 5 minute time. Okay, so we have converted successfully dyne into. Let's now try to find that how we derive a relationship between different fundamental quantities. Okay, the question goes like, if we have took force, we have took length and time as fundamental quantities. If force, if length and if time are fundamental quantities, we need to find the dimensions of mass. Look how this question goes. The fundamental quantities are chosen by us. Okay, there is no greater logic to choose why these 7, other than that these are the 7 mostly used quantities. Okay, if mass was to be chosen as a fundamental, if force was to be chosen as a fundamental quantity, length was to be chosen as a fundamental quantity, and time was to be chosen as a fundamental quantity, and you got to find the dimensions of mass, what's going to be the procedure? I'd say m is equal to f raised to power a, l raised to power b, t raised to power c. And what are these a, b's and c's? These are the powers that we need to find. Once we are successful in finding what a, b, c is, we'll be able to find the dimensions of mass, because we just have to find the powers. How we are going to find? Irrespective of what the dimensions are, principle of homogeneity stays true. Okay, it stays true for any sort of dimension, for any sort of system that's out there in the world. We're going to use principle of homogeneity to get the answer. How we are going to do it? We'll say m. We'll write force. We'll write the dimensional formula of force. How we are going to write it? It will be m1 l1 t minus 2 raised to power a, l raised to power b, t raised to power c. Okay. On the left hand side, can I write it like m1 l0 t0 to make it more understandable and it looks aesthetic as well. It will be m raised to power a if I'm going to multiply a inside, l raised to power a, t raised to power minus 2a, l raised to power b and t raised to power c. Okay. Now, how we are going to write? We are going to write it like m1 l0 t0 and m a bases are same, powers are added, a plus b bases are same, powers are added, t minus 2a plus l plus c. Okay. Now we are going to equate powers. The dimensions of m from the LHS and the RHS, they have to be same. The dimensions, what are the dimensions of m from here has to be dimensions of m from here. So a has to be equal to 1. A plus b has to be equal to 0. Okay, a plus b has to be equal to 0, and minus 2a plus c has to be equal to 0. Now, using the concept of linear equations that you have learned in your class 10, you will put the value of a here, b would become minus 1. You would put the value of c here, a here, c would become 2. So what is going to dimensional formula? M is equal to f raised to power a, f raised to power a which is 1, l raised to power b which is minus 1, and t raised to power c which is 2. This is going to be the dimensional formula of of mass in terms of force, length and time. This is the way we find the dimensional formulas. We'll be posting more questions about all those concepts in the later part. In the last video, a fourth video will be making on numericals only. I hope you have cleared till now. Everything was clear to you. We're going to do a quick recap. Physical quantities can be divided as fundamental quantities and derived quantities. Then we got to know what dimensions are, what units are, what are the different system of units, and how we reduce the relationship between different units. I hope you find this video helpful for yourself. See you in the next video. Till then, take care.